last clip we just discussed Newton's first law and second law. In this clip, what we discuss, that is Newton's third law. Newton's third law is called every action is equal to opposite reaction. Already we discussed. The Newton's third law, by using Newton's third law, the analysis of Newton's third law is very important. Already we just discussed one example, bullet example. So the bullet is fired from the gun. Bullet acceleration is different from gun acceleration. Why? So we'll just discuss this clip. Here, whenever the gun fire the bullet just move forward with acceleration AB. The gun is similarly accelerated in reverse direction AG. So here both the forces FAB and FBG are equal, but any of forces are equal, the acceleration is different. AB greater than AG. Why? Acceleration is more for bullet and less for gun. Okay, according to Newton's law, do you know the force equal to ma, A equal to F by m. Force is the product of mass and acceleration. Even if you apply the same force, acceleration is different because why? Mass is different. A equal to F by m. Acceleration is inversely proportional to mass. So acceleration is inversely proportional to mass. So gun mass is greater than bullet mass. So acceleration of the bullet is greater than acceleration of the gun because acceleration and mass are inversely proportional. Okay, one more example given. From one boat, if a person is jumping to some other places, then the boat move in reverse direction. That is also an example for Newton's third law. Here, next topic that we have to observe is law of conservation of linear momentum. What is my law of conservation of linear momentum? The two definitions are there. The sum of the momentum before collision equal to sum of the momentum after collision, or the total momentum of the one ball collide on another ball is conserved or not changed. The total momentum of the one ball collide on another ball is conserved, that is will not change, or sum of the collision, sum of the momentum before collision equal to sum of the momentum after collision. Now we'll just go to the derivation. Here two example is given. Suppose one ball is moving. The momentum is defined as the motion of the mass of an object. First of all, momentum is defined as the motion of the mass of an object. If two balls collide with each other, then after before the collision just travel to velocity u1. After the collision just travel to velocity v. That is different velocity. So initial velocity of the first ball is u1. Initial velocity of the second ball is u2. Final velocity of the first ball is v1. Final velocity of the second ball is v2. Similarly, if the two cars are just to travel in straight road, first car has a mass m1, second car has a mass m2. Initially, first car travels the velocity u1, the second car travels the velocity u2. So what's the momentum of the first car? m1 u1. What is the momentum of the second car? m2 u2. Then what's the formula for momentum? m1 u1 for the first car, m2 u2 is the formula for second car. Suppose if the sum of the momentum before collision means m1 u1 plus m2 u2. Suppose the two cars in situation, second car collide on the first car, second car collide on the first car. Because the two cars stop, so first car opposes the second car by give the force F1, second car opposes the first car by the force F2. So both the forces are equal magnitude opposite direction according to Newton's third law. So what is the force exerted on the first car after collision? That is m1 into v1 minus u1 by t. What is the force exerted on first car? That is m1 into f1 equal to m1 into v1 minus u1 by t. What's the force on second car? F2 equal to m2 into v2 minus u2 by t. Here v1 minus u1 by t, v2 minus u2 by t, both are acceleration. So F1 equal to m1 into v1 minus u1 by t, F2 equal to m2 into v2 minus u2 by t. So here both the forces are equal magnitude opposite direction. So equate F1 may equal to minus F2. F1 equal to minus F2. 1 equal to minus F2. Equate this. So m1 into v1 minus u1 by t equal to minus of m2 into v2 minus u2 by t. Both side t is there. cancel each other, t is cancel each other. So multiply m1 v1 minus m1 u1 equal to minus m2 v2 plus m2 u2. So if you multiply like that, m1 into v1, m1 v1 minus m1 u1 equal to minus m2 v2 plus m2 u2. After bringing all u on one side, all v on one side, then what's the formula become? m1 v1 plus m2 v2 equal to m1 u1 plus m2 u2. You just write like that, m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. This indicates the total momentum before collision equal to total momentum after collision, or total momentum after collision equal to total momentum before collision. This is called law of conservation of momentum. Here some more, the recoil of gun like that, the recoil moment, some more examples are given. The recoil moment, some more examples are given. Two more examples. What are the different examples? One, you just take balloon filled with the air and tied with the straw and release the balloon. What happened? See here. Here one balloon is just filled with the air and attached with the straw. Okay, on the one rope. On the rope, both the straw and the balloons are attached. Now you release the balloon. What happened? The air is released. So because of that, the straw is moving here and there, just like air balloon. Okay, just like a plane like that. But if you just release the air slowly, then slow motion takes place. Suppose if the in balloon completely air is blocked, what happened? Air is released, what happened? A straw just fly in opposite direction. This Newton's third law, one more example. A recoil. Recoil nature, one more example. Okay. Next, one more example. Take one test tube filled with some other chemicals or like that, copper sulfate like that, or water like that, or soap solution like that. Now you just hold the test tube on the burette stand. Next you fix the mouth of the tube with the cork attached with the stand. Now you just heat the solutions. What happened? If you heat the liquid will evaporate. Then it produces steam. Then steam pushes the cork in some other direction. So the cork is initially towards the mouth in inward, but now the cork is moved outward. This indicates the recoil. Okay, every action is equal to opposite action. Okay, that's all. Thank you, students.